evening. Today we will look into problems related to Nyquist plot and Bode plot. Um, yes, yes. Am I audible? Yeah, hello, good evening. Am I audible? Yeah, okay, we'll start in 1 minute. Okay, just do it. Yeah, I'm sharing the screen. You can look into the question here. Yeah, can you see this question? Yes. Yeah, so we need to plot, we need to know that how the stability of the system by using Nyquist criterion. Okay, so a simple question is given. First, for this, you need to draw the Nyquist plot. Nyquist plot is all about that. So mapping of entire right-half of S-plane into G of S of G of G of S H of S plane. Like if you know that S is a, suppose you know that coordinate system x y. So you are mapping that into f of y equals to f of x form. So that is the way here the system is. So we are talking about that S plane. S plane is all about that sigma plus j omega. So sigma is indicates that is all about that how much the gain. You can say that that real component of it, and omega indicates that it's a frequency component. So we are not doing anything because we are not considering any sigma here, because we need to interest only for understanding the stability criteria by knowing that j omega axis. So we are only uh, doing with as considering the boundary of line is j omega. So now we need to map entire right half of S plane. Suppose I can say um, here you have an S plane. So this is sigma, this is j omega. So you need to map entire right half of S plane. So this entire right half of S plane completely. So this entire right half of S plane, if you map it to f of S function, any function, you can say. So this one, if any encirclements, right? Suppose there is a one some uh, component. You can say one coordinate is there. You can say that it is the 2. So you are mapping into f of S plane. So when you say f of S plane here, so you are mapping this S plane to f of S plane. So suppose if this is lies in the right half of S plane, there will be a, it encloses the origin. Okay, so if it is on this one, so now again it, because number of component which is lying in number of components which is lying in the right half of S plane, will number of encirclements can happen. Suppose you may say f of S we normally define as what, some k gain into S minus z1, S minus z2, and so on by S minus p1 and S minus p2 and so on. Consider z1, z1, z2 and all are p1, p2 and all are positive. Now, so we have here is a Z2, this is Z1, and here it is P1, and this is P2. So this is the way we have this. Now if you map this, if you map um, this Z1 to f of s plane, so this will have one encirclement. So now if you say you are traveling, you can say you are rotating this S plane, suppose you design the one path, suppose. So this entire right of S plane, if you say this is minus infinite, this is plus infinite, is 0, and you consider that half circle, which is infinite radius, you are considering it. So when you are taking a path in this direction, this normally we say this is a contour, okay? So when you are walking along this path, you can see that how many number of zeros and poles. You can say we say Z1 is zeros and P1 is poles. So how many number of poles and zeros which are lying in this right of S plane for one rotation, and each pole and zero will contribute one enclosing. So enclosing origin in the counterclockwise direction. So you can choose that because I am choosing the contour in the clockwise direction. You are walking along this path from minus infinite to plus infinite, having a radius of infinite. Okay, so now for one pole, because it is in the denominator, so one pole gives the, see you are rotating in clockwise, so it is minus 2 pi degrees. So you can say that its angle always measured with respect to negative to positive, right? So with respect to, with respect to counterclockwise, agree? So in clockwise rotation means it will give minus 360. No, actually, last one is related to I have explained about the closed loop system. The time was a little less there. So, but uh, this week I'm covering entirely this Nyquist plot because this week is also having some questions related to Nyquist plot because this is a huge big topics. So we cannot able to cover it in the small amount of time because last time if you see this, so I have explained about all those closed loop system, how we are bringing that closed loop transient and how we are bringing that output response and many things we have shown. So by the time I could not able to, I supposed to do that Nyquist, but it could not able to. But if I bring that more questions, then it is taking long time. If I bring that each one question for one topic, then which covers entire, and that will be fine actually. That was thing. So, but in this assignment also, we have some questions related to Nyquist plot, right? Nyquist and Nyquist criterion. I've seen it. So whatever they have asked in the last one is not that much like it's simple concepts only. But yeah, okay. So one clockwise rotation will give you the minus 360, so that if it is a 0, it will give the minus 360 in the clockwise. If it is a pole, it will give the plus 360. So it is all about the number of poles and zeros which is lying in the right half of S plane. So one rotation will give you that how much angle which can be changed by this. So that is the uh, real implementation of this. So now I have given that one question. It's like f of s. So f of s is nothing but g of s h of s by k into k by s into s plus 2 into s plus 10. So first of all, you map this one. You map g of s h of s considering k equals to 1. Okay. So 1 by s into s plus 2 into s plus 10. Okay. Now what you need to do first, you need to draw the plot for this so that we can say normally polar plot. Once we know that mapping, once we know the plot for this, right, then we need to map this one. Okay, let's do it this one quickly. Now what is the first step you need to do? It put s equals j omega because we are doing with respect to this real imaginary axis, right? So now g of j omega h of j omega is equals to 1 by j omega 2 plus j omega 10 plus j omega. So you make, yeah, this is the one. So try to make it into the uh, in the real and imaginary. You separate that one. So minus j omega, 2 minus j omega is 10 minus j omega. So if you do this, what you will get here, minus j omega, this is 20 minus 2j minus, it will be minus 12 j 12 omega. So minus omega square by omega square plus 4 plus omega square plus 100 plus omega square. So if you separate this, what you will get it here? So plus minus 12 omega divided by omega square plus 4 plus omega square 100 omega square plus, so what is it going to be? Minus j omega, right? It is minus j omega. So 1 omega can be cancelled here. So j 1 by omega square, sorry, what is this? This is 20, otherwise plus, yeah, you better make it minus only, not an issue. Minus 20 minus omega square plus 4 plus omega square plus, so this is g of j omega h of j omega. Now we know this, now this equation, just what I have done, substituted s equal j omega, just making into real and imaginary parts of it separate. Now what we are doing in this, we are mapping this one. So first thing is that we just make that positive frequency. So that means when s tends to 0, so that means s tends to means omega tends to 0 plus 2 plus infinite. How is the plot? Now when omega tends to 0, omega tends to 0, what is g of j omega h of j omega? G of j 0 h of j 0. So how much it is? Substitute omega, it is going to be minus infinite to again j minus infinite, right? So what is its angle now? If you want to see that, what is the angle? See this. So this is the one thing, right? So next, as omega tends to infinite, so g of j omega h of j omega. So what is it going to be? So it is minus 0 minus j. See, it is, yeah, it is omega tends to infinite because 20 will be very small as compared to this. So it is minus minus, it will be plus. So it is omega square, it should be omega here, okay? So omega square by omega, sorry, so it will become omega. So as omega tends to, this will become infinite, right? Clear? Otherwise, so this is a one way. Now the real intention of this one, to make it real and imaginary part, is just to know that whether it is crossing the imaginary axis, real and imaginary axis or not. So that you can do it just by making that imaginary part equals 0 as well as the real part equals to 0. So if you, one more way is that just put s equals j omega, then you can do one thing, you can find out that angles. So magnitude of g of j omega h of j omega at an angle of g of j omega h of j omega. So like polar form. So what is this? If I make it s equal j omega, it will become 1 by omega root of 4 plus omega square root of 100 plus omega square at an angle of, see, 1 by omega means minus 90, and this will become minus minus 90 minus tan inverse omega by 2 minus tan inverse omega by 10. Now it's quite easy now as omega tends to 0. Now what is this? What is this component? As omega tends to 0, then it will 4 plus 10, 4 into 10 into 0. So this 1 by 0 means it is infinite magnitude at an angle of what? It is minus 90. As omega tends to infinite, so because 4 will be negligible, 100 will be negligible, so it is omega square, it will be 1 by omega cube. 1 by omega cube means it will become 0, and tan inverse infinite means it is infinite, that means minus 90 minus 90. So that means overall it is 270. See, the plot at 0 frequency, the plot is having infinite magnitude at an angle of minus 90. At infinite frequency, the magnitude will be 0, angle of minus 270. So, even if you keep omega tends to 0, this will become, the real part will become what it is? It is minus infinite to, right? So, this will become again minus infinite. So, this is the intention of that one, right? Now, what about that? As omega tends to infinite, what happens? This will become minus 0, right? So this component 20 will be negligible, minus minus plus, right? So it will be omega square by omega. So that means, so what you will have here, if you make it as omega tends to, it means omega square by omega into omega square into omega square. So what you will get here, omega cube, right? So now 1 by omega cube means it is again, it will be 0 again. See, is it close enough to the same angle or not? See, this indicates that you should not leave that negative. Why I am telling you? This indicates that angle. So that is the one thing. Now, one more point you need to remember is that if you make the real particle 0, is there any chance, any crossover we get it on the plot is crossover any on the imaginary axis, right? If you make the real particle 0, then we can see that what is the value at what frequency it is crossing the imaginary axis. If you make the imaginary particle 0, we can know that what frequency we can, that real part is having the component. So that means it is, we can say that it is crossing the sigma line. Okay. So if you make the real particle 0, is there any chance this part only will become 0 at omega tends to infinite? So, because if you make this one equals 0, one chance is that, one is that omega tends to infinite, another one is that you can even make it to 0 if omega square equals to 20, right? So, make that imaginary part of g of j omega, h of j omega equals 0, then what you will have? So, it will become minus 20, sorry, so minus 20 minus of 20 minus omega square by omega 4 plus omega square 100 plus omega square must be equal to 0. So then omega comes to be plus or minus root 20. So radians per second. So we are talking about only positive frequency. We should check suitable solution is root 20 radians per second in the 0 to infinite frequency. So what is its magnitude now? So what is its value? G of j omega, h of j omega at omega equals to root 20. Now if you make this, what you will have? You will have minus 12 by root 20. So 4 plus 20, 4 plus 20 plus 100 plus 20. So anyway that component is 0. Now try to solve for this, give me the answer for this. Can you just can say root 5 by 2400. So this is its value. So this value is, sorry, minus. Okay. Now let's plot it now. What is exactly here? Let's take. Okay. Now as omega tends to 0, what is its magnitude? Is minus infinite, right? Now, right, it's minus infinite and angle will be minus 90. Now, at what frequency it is getting 0? It will be 0 at omega equals to root 20. This point, okay? So this point is root 5 by 2400 minus. Now, if you see this as omega tends to 0, infinite magnitude means this is minus 90, right? So this is minus 90 minus 270, right? 0, 90, 270, sorry, 180 and 270 again 360. If you come in this line, so 0 minus 90 minus 180 minus 270 again back to minus 360. So it is all about how you are doing it. Now if you see this, it is starting at minus infinite magnitude at an angle of minus 90 at omega tends to 0 plus, right? So now you say this infinite magnitude, see this is the angle, right? So you can say that this is the way, again it is crossing over this, again it is 0 magnitude at an angle of minus 270. See, this is 270. I am going in this direction, right? So if you see this, at any frequency less than omega equals to root 20, okay? Any frequency less than omega equals to root 20, g of g omega is what? It is all negative real part and negative imaginary part. That means it lies in the third quadrant. Once it goes more than omega equals to root 20, then real part is negative, but imaginary part becomes positive. So this will clear your problem, most of the problem, if you are not able to draw the plot, because Nyquist plot is majorly depending on this, how you are drawing that 0 to omega frequency. Once you know that 0 to infinite, so once you know that 0 to infinite, then it is a mirror image of that one will give you that minus infinite to 0 minus, right? So again, those are all things. Now here, simple only one thing is that it is starting at this point and ending. So this is the plot. This is the trajectory for 0 plus to omega tends to plus infinite, right? Now only one thing if you want to see here, what is its contour? This is polar plot. We can say that real and imaginary of this real part and this imaginary part of g of j omega h of j omega. So we mapped only positive imaginary axis, right? Now what are other things are there? We need to map negative imaginary axis. Is there any singularity? Singularity means the function does not exist at that particular value. Now if you see, if I keep it, if s equals 0, this function will become infinite. So we cannot map. So we should avoid that 0. If s equals to minus 2, right? Anyway, this is on the left of s plane. These two poles, if these two will become infinite, this function will become infinite when s equals to minus 2, minus 10 and 0. But what we are doing, we are mapping entire imaginary axis. That 0 is also included. Minus 2 will be at this point. So we are not mapping those. We don't worry about that. But we have 0 here. What we need to do, function does not exist. So wherever we have a function does not exist, so we need to avoid that path. So that means we say that it's not exactly 0. We should say 0 minus 2, 0 plus. So now define your contour. My point is that define your contour so that we can map that entire plane. So the function does not exist at 0. So I'm avoiding the 0. So we have this, right? So now this will become 0 minus, this one will become 0 plus, okay. So we have a 0 here, we can, so we can have here contour, contour are representing like this because entire like, okay. Okay, so this is, now you can say that omega tends to 0 plus 2 plus infinite is plus infinite to minus infinite, and omega tends to 0 minus. See, now what is its radius? Its radius is, you can say that this is infinite. And what about this radius? What about this radius? This is close enough to 0. Okay, now we are mapping like this. So now when we map like this, so we can see that, yeah, sure. See that assignment I'm speaking actually the topics, because this is advanced control engineering. So the assignments is just like, we need to cover most of the things. So if you take even single question now, that will extend a lot of time. So I'm trying my best anyway. So I will rather taking the too many questions, like different type. I'll take two or one or two which is covering the topic, very good questions. So yeah, this time this assignment is covering the body plot. Okay, so I will be taking kill all this. Okay, this is the only one question. Now we have already mapped. Now what about this one? What about this one? This is a mirror image. This is a mirror image of this one, right? Now we need to map this. Now what about that S component here? See, when S is equals, when you want to map this S, so what is it? It is having a, you can represent this is, we are saying infinite. So let's consider this is R, okay? This radius is R, this is e power j theta. So if you represent this one, so let's consider that rather representing this infinite, just represent this one as a capital R, but R tends to infinite. So again, you represent, so this one, small r, okay, small r. So with the small r tends to 0. You can say this is 0, right? This is the unit. Now let's map now big circle, like having a radius of this. So S is equals to what? R e power j theta. So R tends to infinite. Theta you are moving from what? Is plus pi by 2 to minus pi by 2. Okay? One, yes. Now g of s, h of s, you know that, right? So 1 by s into s plus 2, s plus 10. Now tell me, when s is that varying at infinite radius, what about 2 and 10? It is very less magnitudes, right? So now it is going to be g of s, h of s, as s equals to r e power j theta. Now this function will become, what about this? R, it is s cube. S cube means r cube e power j 3 theta. Now if I represent this one, this will become what? 1 by r cube e power minus j 3 theta. I can say this, I can write it in this form, r at an angle minus 3 theta. So g of s, h of s at s equals to r e power j theta, or r at an angle theta. So now r tends to infinite. and theta is when if r tends to infinite, so theta is equals to plus pi by 2. Okay, so what is actually happening? What is its value? So g of s h of s will become now, it is r tends to infinite 0 magnitude, angle will become minus 270, right? And r tends to infinite, theta is minus pi by 2. So what about g of s h of s? It is same magnitude, but angle will become 270. What is this real intention? See, when you map this entire this right half of S plane, this entire half circle, so that means you are moving this path in this direction. So you are going in this along this way. One path, one traversing, because when traveling from this edge to this edge, covering entire half circle, so you are covering only 180 degrees. But this function is covering how much degrees? 190 will give the 270, right? Because of s cube, we have 190 will give 270, right? So when you cover 180 degrees, it will cover how much? 270 times 270 into 2. So one is covering, one s will give 180, another s another 180, another s will give another 180. So it is 3 into 180. So you are going in clockwise. That's why it has to traverse in the counterclockwise, right? So because you see plus 90 to minus 90, it is traveling minus 270 to plus 270. Just keep it in mind. Okay. So one more thing for one last. What is the next one? Next, s is equals to small r e power again j theta. What about r here? It is tends to 0. And what about theta? It is minus 90 to plus 90. You see this minus 90 to plus 90. This is like this. So, and minus 92 plus 90. Now, what about this g of s, h of s? See, when r tends to small r tends to 0, these components will be very, very small, right? S plus 2 will become close enough to 2. S plus 10 close enough to 10. So, now g of s, h of s at s equals to small r e power j theta will give 1 by 2 into 2 into 10 into s. That means it is 20 s. S is nothing but 20 r e power j theta. That's all. Now, if r tends to 0 and theta is equals to pi by 2 minus pi by 2, now what about this g of s, h of s? G of s, h of s will become 0 magnitude means infinite at an angle of minus pi by 2. If it goes up, it will be plus pi by 2. See, it is rotating in opposite. You are rotating in the counterclockwise here, counterclockwise, but actual f of s plane is rotating in the clockwise. Okay, theta equals to pi by 2, g of s, h of s is equals to infinite, again it is minus pi by 2. See, now you know mapping for this, you know mapping for this, you know this, you know this path. Now this path is just like mirror image of this. Now let's do that. Let's do that how. Okay. So let me draw for positive. So what is their positive? It is like this, right? So this is the path. Omega tends to 0 plus to omega tends to plus infinite. And next path. So next path is what? It is mirror image, you can take it. So what is the mirror image of that x-axis? Is like this, right? is omega tends to minus infinite to 0 minus. So this is in this stage. You try to okay. This way. Now let's map large small circle. This one. What you are doing? You are rotating counterclockwise, right? So when when it is 0 minus, right? When it is 0 minus and this is 0 plus, okay. Now, so when it is omega 0 minus, it is minus angle means it is plus angle. Infinite magnitude. Here it is, right? Infinite magnitude at angle positive. This is 90 plus 90, right? This is plus 90 and this is minus 90. This is 0, we can say plus or minus 180, right? So now in this case, what is going to happen? See, you are traveling, you have to draw the path plus 90 to minus 90 with a magnitude of infinite. That means this entire comes. So this is the path. Now you need to map that large circle. What is that? You have to get 3 enclosure. So I said that this is very close enough to 0. See here, if you zoom, if you make it to very close enough to 0, this magnitude is going to be 0, but not 0. This also going to be 0, it's not 0. So you need to make it like 1s. What is actually happening? Suppose if you see, you are making a path for how much? Plus 90 to minus 90, right? But this is moving from minus 90 to plus 90 for each s, right? For 1s. So now plus 90 to plus 90 to minus 90 you are moving. So it has to move minus 90 to plus 90. So here only it is minus 90 to plus 90. So yeah, what is this? This is minus 90 to plus 90. When you take omega equals to, okay. So you make the path like this. So here only it will rotate one path here like this. Again here another and here. We cannot make it now. It's just like we can say this is one angle, again another angle, again one more, like this you can say. So like that 3 into minus 182 plus 180, like this you have to make 3 times. So if you make it very close enough, that is because anyway 0, we can close enough to show this 0 only. So you have to travel, you have to go minus 90 to plus 90 for one s, another s again, another s again. So that means you have to cover like this, right? See, minus 90 to plus 90, plus 90 to again, plus 90 to minus 90, minus 90 to plus 90, again plus 90 to minus 90. So that means it is 3 times, okay? Like that, it has to be there. Now this frequency is what? This frequency is nothing but omega equals to root 20 radians per second. Now this is we consider at omega equals to, at k equals to 1. Okay. See, we assume that k value will be 1 here. So k will be 1. Now if it is multiplied by k, then what happens? This will be k here. So here this 1 will become k and this is omega k and this is k here. Everything will be k, right? So it should be k must be multiplied by k times, right? This one will become k. Now when it is become k, now what is its magnitude here? Magnitude I got it as a root 5 by 2400. So root 5 by, so at this frequency, this magnitude, the magnitude, you can say this magnitude is equals to root 5 k by 2005 2400. Now see, we always interested in finding the stability now, right? So when we say we have the transfer function g of j omega h of j omega, so we say that transfer function is equals to what? G of s by 1 plus k g of s h of s. Suppose this is k. Now only we interested in the denominator part. This is characteristic equation. Del of s equals 0. For certain values of k, the transfer function poles will be on the left half of s plane, so that the system is stable. We say that. Now if we make it 0, then g of s, h of s will become what? Minus 1 by k, right? So magnitude is equals to what? It is 1 by k. Angle is equals to what? It is 180 degrees. It is 180, plus or minus 180 means it is 180. So the magnitude should be 1 by k and angle should be 180. So if k equals to 1, that will pass through minus 1 plus 1, right? It's a half circle, right? So angle will be this. So if this circle, unit circle, suppose if you draw that unit circle, so you just look into this. This is the one. We need to find that, okay? So 1 is here, minus 1 is here. So with respect to that, what is its magnitude? So if I multiply this one by k, suppose the magnitude will multiply by 1, it will become 1. So right, then only if this is 1 by k, then you can say that it will be magnitude is considered to be what? 1. So if this is a and if this is 1 by a, then we can say that always it should be less than that, right? So root 5k by 2400, that's 1, you can say 1 by, so 1 by a means 2400 by root 5k must be greater than 1, right? So it should be less, this one should be less than 1, so 1 by a will become greater than 1. So k will be what? Root 5 by, sorry, 2400 by, so k must be less than 2400 by root 5k. So for these values of k, the system is stable. So that means if this k equals to 2400 by 1, then this will move, this plot, this trajectory will move towards like this. If k is increasing like this, at one instant it passes through this. Exactly at this point, it is having an angle of minus 180 or plus 180 and magnitude of unity. And if you increase further, what happens? It loses, it crosses this one, so that the poles will be on the right half of S plane, right? So now you draw this unity circle. So at one S, its magnitude, see, it is crossing this one. The angle will be what? You draw a line exactly, it crosses this magnitude is 1, you can say that. So at this point it is crossing. So whatever angle which is offering at this frequency, and how much is the difference from this one is nothing but the phase margin. So we need to find it out with reference to this. Whatever the gain which is offering with reference to this one is nothing but the gain margin. So we have this much margin till the system can be stable. So always we must have the high gain margin that is close enough to infinite. Phase margin should be always should be 180 degrees, so that the system is stable. So it is yeah, yes, yeah, yes. So this line, you see that, right? This line. So this is the line. Exactly at one frequency it crosses it. So if you make it, if you want to stop, yeah, 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 its magnitude must be one. At that frequency, the phase you have to calculate, and that phase you should, you should determine with reference to 180 degree line. So this frequency we normally say that gain crossover frequency. This frequency we say that it is a phase crossover frequency, because we have this much margin. This is gain margin and this one is the phase margin. So now if you see from this, so we can try to know that. So you can say if you bring k this side, k g of s h of s magnitude is equals to 1. So this one. So that means what? You should make the magnitude is equals to 1. That is only possible by this line. So that frequency we say that it is a gain crossover frequency. The angle, if you make it this one, so then you will have the phase crossover frequency. Whatever the magnitude you calculate at this frequency will give you the gain margin, and for this at this frequency you will get the phase margin. Okay. So this is all about the Nyquist margin. Any doubts for this? Okay, let's move to another question. Very quick questions for this. You need to determine, yeah, you can see the question number 2 here, right? See, you need to find it out now, gain margin and phase margin. Okay, so with respect to this, yeah, can you answer this question number 1? Question number Roman number 1. Just now we have seen. What is the gain margin now? What is the gain margin and phase margin? Yeah, gain margin is 10. Perfect. Because so this is point 1. So 1 by point 1 is nothing but the gain margin. So what about the phase margin? Phase margin. Yeah, yes, 40 degrees. Because at this frequency it is offering minus 140. Otherwise, so you need to find out the difference between these two angles. Okay, this angle you need to calculate. This angle 180 minus 140 will give 40 degrees, right? Now for the second question, yeah, what is the gain margin for second question? Yes, it is infinite. It is infinite because it is touching at what? It is as omega tends to, this is as omega tends to infinite. So the magnitude will become 0. It never touches the real axis, right? Negative real axis. So that means it never touches means its margin, gain margin magnitude is infinite. So it almost like a, if you talk related, if there is no condition for the phase margin, you can say system is stable here, right? This is stable system, right? And what about the phase margin now? The phase margin again 30, yeah, it is 30. So we don't have any condition for the phase gain margin, but we have a condition constant for the phase margin. So the system, as frequency increases, right? As frequency increases, suppose the phase has to be reduced. Suppose the phase has to be reduced. Now what happens? So it exactly Now here you see that the phase is getting reduced. Now, now that means this will have a constraint for the phase margin. So if it goes enough to 0, then we have it's a boundary system. You can say that it's a bound edge of that stable system, stable unstable system. If it goes, then it is unstable. Now, can you give the answer for this third one? This is also stable system. Now, third one, gain margin is, so it will be 2. Yeah, phase margin is, yeah, phase, it is not cutting the, so it is not at all cutting the unit circle because this is 0.5. So this is here 1. So it is, the 1 will be, if you draw this line, it is not at all cutting. So that means phase margin is right. Now, what about the question number 4? Yeah, it is minus j. Minus j means angle is, magnitude is 1 at an angle of minus 90. So, yeah, so sorry, this one should be drawn like this. This is, yeah, like this. So it is not at all cutting this unit structure. So that means infinite phase margin. It not at all possible. Where it is cutting, yes, 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 yes. Just, yeah, right. Yes, yes, it is 90 degrees. Yeah, it is 90. Sorry, my mistake. Yeah, right, right. Okay. So here it is not at all cutting. So both are infinite. Infinite means at any constraint, at any condition. So that means that the gain margin and phase margin both are not at all related. So you change any parameter in the system. Okay, some constant you have say that gain. So you say that you have k g of s h of s, right? So h of s is there. So you are varying the parameter k. By varying k, any loops, and poles of the system, characteristic equation poles. So always lying on the left of S plane. So it doesn't have any role over it. You change this parameter, the system always gives the bounded input. For bounded input, it will give bounded output. So that means there is no relation. That's why we say that it's a. So if you talk about this 1 by 1 plus s, so k by 1 plus s, suppose. So what is it? So for a step input, always it will give that. So what you can say, now you have a first order system like this, capacitor. Now, now you close the switch. Now always it will give this way. See, it, phase margin can be, no, we can say that, right? I need to correct it, I think so. I need to check once. Yeah, yeah, maximum will be 180, yes. Because here if you see that, yeah, this will be angle, boundary angle will be, it is all 180. I will get back this if it is so. But yeah, I need to verify this. Because my question is that if it is not touching anywhere else, so whatever angle difference you find it out, so it will be 180 plus or minus angle theta. This theta is now not known. My point is that if you are subtracting this, so whether this phase margin will become what you say, this will be undefined now. So that is my intention to say that is infinite. So but again I will verify once again. Okay. Yeah. Yeah. Let's go for a body plot here. Yes. So you need to draw that Bode plot for the transfer function which is given, right? So normally Nyquist plot is having an advantage when we have the systems like having a delays in the time domain will give that exponential multiplication of exponential component that e power, you can say, suppose a step signal is having delayed by some t units, t minus capital T. So this will, when you do this one, it will have e power minus ts. Now, what about this magnitude is always 1. What about this angle? It is in terms of omega t. So, in stability wise determination, so this is having a better easy way to give the stability. So another thing is that Bode plot will give the best way of stability only for the non-minimum phase systems, right? So minimum phase system. So now it's just like one pole will give, first order pole will give minus 90, first order 0 will give plus 90. So now if it is s minus 2 pole, if it is 1 by s minus 2, then the phase with magnitude we can say that, but what about that angle? Angle will be because of that sign, so it is not exactly minus 90, it will be other than that. So we can say that it is a non-minimum phase system. So for non-minimum phase system, Bode plot, Nyquist plots are the best way of giving that stability. For this, you can Bode plot will, yeah. See, we most of the practical realizable systems having a poles which will be left off of S plane. Agree? So now certain conditions. Suppose we give some gain parameters. We design a controller such a way that so now system may have that certain margins. So it might be becomes unstable. Now when we say the system poles, suppose such a poles does not exist, but we can say that S minus 2 or S minus 5. So what we see, if we make it magnitude and angle of it, so one pole, first order pole, which is on the left of S plane, as omega tends to 0 to infinite, the angle will be, it will be 0 to minus 90. You will get that one pole causes minus 90 max. So 1 0 will give, it is 0 to plus 90. Now, right? So we know that how the phase is being changing. So that's why we can say that it is a minimum phase system. So another thing, if we say S minus 10, S minus 10 means it is a second quadrant. So how can you write it this one? It is minus 90 plus theta, right? So you need to find the angle. So this is at this point. Suppose what is this angle? We supposed to be expect of plus 90 for a 0. But for this, the angle is more than 90. So that means we are not expecting what we are getting. So this is called non-minimum phase system, right? So for this, I think Nyquist plot will give you the better way of giving the stability because mostly it is a mapping of the entire right half of S plane. So you need to find out how many number of poles and zeros which is lying in the for that circle. Then how many number of encirclements you are getting. Based on that, you can just say that whether the system is stable or unstable. But doesn't speak about that. What is the constraint for it is required. So now my point is that most of the practical realizable systems have the poles in the left half of S plane, right? So, but because we design a controller such a way that the system poles may go in the right half of S plane. So depending on the what parameter you are controlling. So, but Bode plot will give you the best way of understanding how the system is exactly how the system is getting unstable. Okay, so you can know that, you can see that. So what is the, whether it is a, in that particular region, whether it is a system is a completely acting like a first order system or second order system, or just like a, you know, like you can see that, that is how you are making the controller. That is the one point, right? That is I was telling. Is it clear? Yeah, thanks. So now, what is the first step you need to do? Mostly, the standardization we follow that. So we replace that s equals j omega. Before that, what we need to do, we must represent this one as like some constant k into 1 plus st1, 1 plus st2, and so on. That s into, you can say this power p, right? And again 1 plus s, uh, you know, sg1, and 1 plus sg2, and so on, right? So here s is nothing but 1 by omega t. If you make it this one, if you say, I'll speak about this, if you make this magnitude is equals to, you know, 0, you can say exactly, if you want to find it out. Why we say asymptotic plot means, if you see that exact plot, asymptote is all about what, tangent at that particular frequency, right? So now we will have expect to be like this, but what we say, at that frequency we have that one plot, and we have another plot at this one, both at meet same point. So we are just drawing this is as a tangent type base, so we can say this is an asymptotic. So at this point we can go for an approximation. So at that frequency both magnitudes will be equal. Okay, so now if you bring it into this form, so put s equals j omega, sorry, now change it this one, that one. So 10, if you take 10 common, so this will become 10 into 10, this will become zero point 0.1 s. So s, if you take 2 common, 2 and 5 you can take it common, right? So 2 into 5 into s, so 1 by point, that means 0.5 s, 1 by, so it will be 0.2, 0.2 s. I think this one will be, yeah, yes, fine, right now. So what is the final expression for this? 1 plus 0.1 s by, it is s, 1 plus 0.5 s, 1 plus 0.2 s. So this is g of s, h of s. Okay. Now put s equals j omega. So 1 plus j point 1 omega. So j omega 1 plus j point 5 omega, j point 2 omega. So let's draw the magnitude plot first. So what is it becomes? 1 plus 0.1 omega square omega, 1 plus 0.5 omega square, 1 plus 0.2 omega square. Okay, so now thing is that now we need to make that what are the corner frequencies exactly. uh, so this is just like the approximated plot, right? So because whatever the frequency of this, you can say the slope of this one. So what we are doing, so normally we are drawing this plot with a scale of log omega with a magnitude is in dB. So this one is in dB. So it's a log scale, semi-log scale. So whatever the thing you are doing, right? Whatever just one decay will give you that 20 dB. So just like if you say this one decay will give you the 20 plus 20 dB per decay for 1 0 and minus 20 dB per decade for one pole. So if it is a second order, you will get double. So the slope of double. So normally magnitudes we represent as in dBs, right? So if you make it again 20 log magnitude of j omega h, so this will become what? So 20 log, sorry, this one will be minus 20 log omega plus 20 log root of 1 plus 0.1 omega square minus 20 log 1 plus 0.5 omega square minus, so now multiplication and division will be sum and subtraction, right? 0.2 omega square. Now say that first, yeah. So you need to identify that what are those corner frequencies. See exactly the plot changes at what frequencies. See. So now if I say 0.1 omega is one corner frequency. If it is more than that and less than that, what is that plot approximation? If it is, now you need to identify that, right? So if you make this one, what are those frequencies? Exactly, one is 2 radians per second, 5 radians per second and 10 radians per second. Now if you go for this, if omega is less than 2 radians per second, so that means 2 radians per second means, so what is there? So this component, so let me take another. This component will be very small, and this is anyway it comes later. So this is also very small and this is also very small. So what is it? 20 log root 1, 20 log root 1, 20 log root 1, it all gives 0. Only this component exists. Now more than 2 radians per second but less than 5 radians per second, what it comes? This magnitude will be very small, so that 20 log 1 will become 0 and this is anyway false, so this will also be 0, but this is not negligible. Now both will come. So this is already minus 20 and again minus 20. So the total slope will be minus 40 dB per decade. Okay. So because here 1 is negligible, I can write this one as when, so let me write. So corner frequencies are, it is 2 radians per second, 5 and 10 radians per second. So you can simply say that 1 by T1, 1 by T2, 1 by G1, 1 by G2, right? So now if omega less than 0.2, if omega less than 2 radians per second. So what is the approximation? 20 log magnitude of g omega h of j omega. This will become, this component will be very small, so that I can neglect this. So I can neglect this component, it will become 0, 0, 0. So what is left? 20 log omega. If you differentiate with respect to log omega, so what is the slope? Slope is how much? It is minus 20 dB per decade. So here log scale, so you should different 20 log g of j omega h of j omega by d of log omega, then you will have that minus 20. So that means that magnitude vary with a slope of minus 20 dB per decade. Okay. So second thing is that now if it is more than, if it is more than 2 radians per second but less than 5, okay, next corner frequency, next frequency, more than 2, less than 5 radians per second. Now which is dominant now? So magnitude will become 20 log magnitude of g of j omega, h of j omega will become what? See, this is cannot be negligible, minus 20 log omega. Now if you substitute between anything, this is negligible, still it is 0.2. 0.2 square will become 0.04, so even it will become lesser, okay, square. Now this cannot be neglected and this can be neglected, right? Because this will become 0.2 into 5 will become 1, so at that only it is having the appreciable value, so otherwise before the square of that one will even given less. So we can say that 1 can be negligible here, so that you can write this one as minus 20 log, so 0.5 omega, right? 0.5 omega. Now again you differentiate it, so this will again it will comes as a slope of minus 40 dB per decay. See, second pole is done. Now let's go for more than 5 and less than 10. 5, right? So what is it going to be? 20 log magnitude of g of j omega, h of j omega. So what is now here? What is negligible? See, now this comes, now more than, so next this one also comes, right? So if you give 10, it will, if you multiply omega, 0.1 into 10 will be 1, so this can be negligible. So you can consider 3, so 3 poles are coming now. So that means minus, you can say slope only matters, right? 20 log 0.2 omega. So what is the slope now? If you differentiate, this will become minus 60 dB per decay. So now you see this polar, now more than 10. Now more than 10 means it is in up to infinite. So if it is more than, sorry, more than 10, now what is happening? Now gets the magnitude 20 log magnitude of g of j omega, h of j omega. See, now nothing can be, right? So minus 20 log omega minus 20 log 0.5 omega minus 20 log 0.2 omega plus 20 log 0.1 omega. So you substitute any frequency more than this, then you will get the magnitude. But we are drawing asymptotic laws which slope matters, right? So see, if you differentiate, then you will get minus 20 dB, minus 20 dB, minus 20 dB, plus 20 dB. So again it will become minus 40 dB per decay, right? So this is the thing. Now let's draw the plot, magnitude plot. Yeah, so this is 2 radians, and this is 5, and this is 10, and goes on up to 2. What is that? It will be minus 20 dB per decay. So you can calculate it. So this is 1, you can take, you can know that what is the 20 log, how much it is? 20 log 1. So that means it starts at 0. So you need to find out that initial value. So 20 log 1, at this point up to this frequency, it will be 0 magnitude. Let me take another color. Yeah. So up to this. So this will be 20 dB. So minus, sorry, what is that? It's minus 20, right? At 1, omega equals to 1, it will be 0. So up to this, it will be minus 20 dB. Then after 2 to 5, it will be minus 40 dB. So minus 40 dB. Little bend, you can say. Again minus 60 dB. So one more. Again Again, more than 10, it is 40 dB again. So consider that I will just mention here. This is, sorry, this is minus 20 dB per decay. This is minus 40 dB per decay. This is minus 60 dB per decay. This is minus 40 dB per decay. This is a system function, right? Yeah, this is the way we draw the magnitude plot. So normally these are the corner frequencies. So you can calculate the magnitude. Okay. So either using by the slope method or you can use it by the uh, actual plot. So actual plot and this one asymptotic one will have that 3 dB frequency error. You see that suppose if I keep s equals, if I substitute s equals to omega equals to 2 radians per second. So then what happens? This will become 0. So you will have the 20 log 2, right? Now when I substitute, if it is now here what is it? 20 log 2. So at this, at 2 radians both will be same value, right? So now if it is more than that, now exactly at that corner frequencies both value will be same, but if you make it exact plots, what you have a little like this. So if you make it, you can find it out exactly. There is a error, small error, right? So that error you can consider, but it is a quick way to solve this because whether the system is, how is the plot. See, up to this first order system, second order, third order, again second order, right? In this frequency region, the system is acting like a second order. Again, in this frequency region, it is acting like a third order, second order, first order. Now, suppose if you want to control this plant, you can say that this is the system function. Suppose you want to control some parameter of it, so you know that parameter. So suppose you design the controller, so controller GP of S, some magnet that you know that. So you want to control system poles or can system functions by varying some parameter. So now loop transfer function will be controller function and the plant function. So if you multiply those two, then you will have that actually, right? So by varying what parameters, how the system is going to be have the whether it's the first order, second order, third order. Okay. So now the best way to bring that system function is always first order, trying to bring design a controller such a way that system can have the only first order response in that frequency region. So that bandwidth of the system will be little higher. So this is all Bode plot helps a lot. You can say the best way of designing the controller, Bode plot. So Nyquist plot and all these things is if the system is having some delays or like how this poles and all. If root locus also can be used for determining all these things. Okay. So root locus will give you the exact location of the poles, trajectory of the poles. Nyquist plot will give you that how is the system function. So when we have these like delays and all, so even though you can do that for any whether minimum phase, non-minimum phase, whatever it is, you can do the Nyquist plot also. But we can understand that whether the system is a first order system, second order system, whether in the frequency region, that you can get best out of it from the Bode plot. Now, what about the phase plot? Phase plot is just like a, you have to just get that angle of this one. Yeah, bandwidth of the system. Yeah. Suppose normally, because I'm a power electronics background, so suppose I have uh, suppose I can say that this is a DC to DC converter. You know, right? Related, any idea about? You have little understanding? Yes, yes. So I want that output voltage as well as current. Okay, I not. So input is Vs. I want to make the voltage constant in the output. Okay. So let me draw the circuit also, not an issue here. Simple, you take that buck converter, okay, generalized one. So what I need to do, I need to control this, I need to control the switch on and off times, just in such a way that I need to get a voltage across this load will be always constant. So what I do, I'll take the feedback signal, right? I will take this feedback signal and comparing with the actual reference value. So I want to maintain always 40 volts. So this voltage you can take as the 100 volts. So now I compare this one with reference to actual value which I want 40 volts. So it will compare till that whatever whatever the changes which is happening in the system. So I will have the plant transfer function output versus with reference to the turn on time duty. So I will get that voltage versus D. So that is a one transfer function, right? Now what I need to do to control this one, this average, this error, we are giving the controller, that the PI controller, you can say that. So the PI controller, you need to make the system, right, very fast. Suppose this plant is like, you can say that second order. See, because L and C is here. So definitely it is a second order system. So if the second order system is there, so normally what you can expect, omega n square by s square plus 2 zeta omega n plus omega n square. Normally we have the damping. So you can say that the system poles will be a, sigma plus or minus j omega minus sigma. Sorry, plus sigma, yeah, minus sigma. So these are the things. Now we will control such a way that we have that Kp plus Ki by S. So this is the transfer function. Now what I need to do, so I can, these are the complex poles. So you can say that S plus P1 I can write it, and so S plus P2. So this one I can write it as a, you can say S plus, so this will give 1 0. So you can say that S plus Z1 divided by S because of 0 at all. So now what I will do, I need to make the system to be first order. So this, with this it is not possible. So what I need to do, I need to make the system first order by just giving the second order. So you need to change the controller now, PID controller you can take. So I choose such a way that this one get cancelled, this one get cancelled. Now Z1, Z2 is equivalent to P1, P2. Now when you make this one, this will become now entirely omega s. Now G of S, H of S will become omega n square. Now what is the now overall system will become, this is entirely becoming as omega n square by S. You can consider now it is a unity feedback. So now overall system will be what? It is just like a first order, right? So omega n square by S by 1 plus omega n square by S. This is the overall transfer function. See, now the system will become first order. So you will not have any damage. So my point is that you are saying bandwidth. Now bandwidth is all about that. How frequently, what is the switching frequency of it, right? So based on that, how fast you need to bring the system response. Suppose you are designing this buck converter for the CPU processor, so you demand a very fast response, very fast dynamic response. You are designing this buck converter, this converter for the maybe like mobile charger, so you don't need demand that much fast response. So you can compromise there. So bandwidth is all about that, how you much fast you want it. So based on that, whether you want to bring the system response to be first order or you want to bring it to be faster but doesn't have any issue related to like overshoot. So that can be considerable. That overshoot can be considerable. So even the second order system, but the way. So the bandwidth is all about that. So you can say that suppose the system is first order, I can say I have this way. Now I choose this Kp value such a way that suppose I made this one just omega n square by S. So what I want, see this is the minus 20 dB per decay line. Minus 20 dB per decay line. Now suppose this one is coming with a kb, sorry, because here is a kb is there, so kb will come. Now I need to vary the kb. Suppose I want the bandwidth, so this is coming at some frequency. Suppose you can say that omega 1. See, up to this whatever the signal it is there, so that will give you the only first order response. So what is a closed loop response? Closed loop response will be, it is 0 dB. You will have that. Then after that the magnitude will be very very less. It is going to be decreased. So up to this omega 1, you have that error to be 0, but you have the open loop, it will be minus 20 dB. Now I want to increase the system speed. How you will increase the system speed? Just by increasing. Suppose now I want the bandwidth to be omega 2, right? What you will do now, next case, you will increase the, you will shift it out. How you will shift it out? By just varying the kb. So now I will bring this way. So now if I want to increase this bandwidth, the system will be having a little faster response. It will have maintained that 0 dB line up to this. These are the closed loop, and these are the open loop, right? So this is the way you need to choose the kp value. Normally I controller, I controller, PI controller, normally what if alone P controller is sufficient, but only thing is that what happens if you use alone P controller, so you demand the system response to be stays at this point. This is your final response, because if you use a alone P controller, there always exists a steady state error. So why it exists always steady state error? Suppose if you use a P controller, you will not have this S below. So always it is having a Bode plot. Bode plot, if you see this, okay, let me take a. If you don't have S, always what it is always starts with the 0 dB line up to entire frequency. Always it is, always for any frequency it is. So you are getting only constant magnitude there. That means it is independent of that. You will always expect to be some error there. So if you have a proper I controller there, so what exactly happens? You demand very high gain at the low frequencies below bandwidth, so that the error will become 0. Agree? So at these points error is almost coming to 0. So this very high gain at the low frequencies brings the error to be 0. And now if you want to increase that bandwidth, then only thing is that you need to change the kp. So alone proportional controller will not make the system error to be 0. Steady state error always exists. But if you use the PI controller, only one thing is that you have that error to be 0. As well, there is a limitation on the bandwidth. So that you need to figure it out. It is depending on what order of the controller you are choosing it. Second order, third order, or first order. So simple, that you need to figure it out. Okay. Am I clear? Yeah. So in this case, the phase plot is exactly because it is a minimum phase system. So up to this, if you draw it, so I can draw directly here. So up to this, it is what, minus 90. Then it is moving towards exactly to, at this point you will have a minus 180. Again it is going to be minus 270. Again it is going towards minus 180, like this. Minus 90, minus 180, minus 270, again back to minus. That is the way system. Okay. So as omega tends to infinite, what is the thing? It is just because it's magnitude plot, it is a minimum phase system, means it has to follow that magnitude plot, right? So there is no way of doing that phase plot. There is only you have to substitute s equal j omega. You get all that phase minus 90 tan inverse omega by tan omega by minus, sorry, tan inverse omega. You just get the phase of it, substitute omega values, then you will get the phase. So just you can get that phase plot. So magnitude plot will definitely will give that. So exactly, um, if it's 0 dB line, so what is this? 1 plus k g of, suppose k you make it 1. So if you say g of s, h of s is equals to 0, so g of s, h of s is equals to 1 minus 1. So magnitude will be 1. So magnitude 1 means it is 0 dB. So if this magnitude plot touches 0 dB line, there you will get that gain crossover frequency. At that point, you can find out the phase margin, right? Now, so yeah, then again, now you have the phase plot. What is its angle here? 180. So, so then exactly whenever it touches its 180 degrees, so there you draw it, then you have this is the gain margin. Okay, so here it is what, here at this point you have the 0 dB line, so then you have a phase margin is this much, like this. Okay, so you can find it out this one also. Yeah, I think phase margin cannot be infinite. I think it is always axis 180 because the limit, right, it's not infinite, it's nice. Okay, now let's go for the last question. You need to bring out the asymptotic plot. Yeah, please. Yeah. What is your doubt? How first term will be log 20? Okay. Now here you have a, yes. See, this is the transfer function. Now you find the magnitude of it. Okay. So in this case, if I suppose what is the order? It is 2, 5, 10 radians per second, right? So if it is omega less than 2 radians per second, if less than 2 radians per second. So here 0.1 into 2 will become 0.2. 0.2 whole square means it is 0.04. Adding 1 to this one in log scale, so it's close enough to 1 itself, right? So 2.5 into 2, but you are making less than 2. So if it is more towards the close enough to 1, so this value will also become 0. It's very negligible. So you can take it as a 1. So here also it will be decimal. So this component is also very small. So now neglecting these, all these three will give only 1, right? So log 1 will become 0, right? So you have only minus 20 log omega. So that means initial very close, you can say as close towards, as frequency reduces, it is like, close enough to log omega only. Very high gain. Now more than 2, less than 5. More than 2 means if it is more, if it is 0.5 into 2, then what you will get? 20 log 2. So here what is the 20 log 2? It is 3 dB frequency, right? That is the error, but we are not considering. What we are considering, if it is more than 2 means it is more than 1. So square of will be even little higher value. So 1 can be negligible. So then you can say that 20 log zero point 0.5, right? And this one will be negligible. So you have this one as well as this. If you make it differentiation with respect to log omega, then you have a slope of minus quantity, like that you have before. Now you need to bring out what is the yeah, what is the exact transfer function of this? Is the one last question. See, the first frequency is that it is said that minimum phase system. So you know that it's all, you can say that standardized, right? There is no S minus 2 or 2 minus S, something not like that, okay? So initially it is minus 40 dB per decade, right? So now this one is minus 20. So from minus 40 to minus 20 means there is an addition of 0. So minus 40, because we have seen minus 20, minus 40, minus 60, again minus 40. That means there is a 0. That's why we have a addition of 20 dB. So there, if we have a 0, then it will give plus 20 dB. You have to add it for 1 decade, right? If it is now again it is minus 60 dB. So minus 20 to minus 60 means there is a minus 40. There is a, either it may be a second order system of quadratic second order system, or you can say that two poles, first order poles of same, right? So that you need to do it. So now you see 0.1, 10. So you can determine this one, right? How can you determine? See, this is 0 dB line, right? Now you know this one, you know this frequency, you know the coordinates, right? So you know that 20 log omega, right? So use the slope dV versus decay, right? So now how you will find y2 minus y1 by x2 minus x1. So what you will do, y2 minus y1 means, suppose you don't know this magnitude. How you will calculate? What is the first thing you know? See, at this point you know the dB as well as the frequency. At this point you don't know the dB, but you know the frequency. So you know the slope. So what I can write, 20 minus, I don't know, I can take this one as y1. So 20 minus y1 divided by log 10 minus log 0.1 will give minus 20, right? So now this will become 20 minus y1, 1 minus, how much it is? It is, yeah, plus 1, it is, so it is going to be how much it is? So y1 will give minus 40, no, something is wrong. I think I taken wrong by that, right? 20, yeah, this, I have taken upward, yeah. This will become what? Minus 2. So this will become 40. So if you become, this one will become minus 20. Okay. So that means this is not 0 dB. So this will become, this is, this y1 is minus 20 dB. Now you know that minus 20 dB. So 0 dB line is here. So we don't know, just that's why to confuse you, just I made it like just diagram, right? But you need to find out that exact value. So y1, you know that now. Now let's calculate this one. So you need to calculate x2. So what you know now, you know this one, you know what is this, you know the slope, right? Right? So now exactly at this frequency, do we need this actually? Tell me, do we need this? We don't need, right? Wherever the plot is having a changeover, that corner frequency only we need it, right? So we don't need this, because if we want to know what frequency it is, then we need the information, because I need this information. Because asymptotic plot, we know only that, see, only the changeover is happening at this point, one point, another point. Later we don't have any changeover, because we need to bring the g of s, h of s. So now tell me, what is the order? Now, if it is less than zero point 0.1, if it is omega less than zero point 0.1, now what is the frequency, what is g of s, h of s, you can expect? It is second order minus 40, right? So it means some, you need to calculate this one also. Suppose you can take this one as a some k, okay? Some k by s square. So it is 0.1 to 10. So what is happening? It is added 1, 1 0. So that means g of s, h of s is equals to how much it is? This is 1 by t1, right? This is 1 by t1 and 1 by t2, right? So this will become st, right? So now k by s square into, now what is this, 1 plus st1, that means it will become 10s, right? Now more than 10, so 10, right? So g of s h of s will become k by s square 1 plus 10 of s. This is same. Now again it is minus 60 dB. So consider it is first order, okay? So because it is like a straight, if something they say second order, they particularly mention it, okay? If nothing is mentioned, you just take it as a direct first order, two poles, same frequency. So then it is 1 plus 0.1 s whole square, right? So now we need to calculate the k. So what is the k value here? Now you know this, right? How you will, because at this point you know this one and this one, you know the slope. Is it possible to know this one? You need this one also, right? To know that one. Yeah. Yeah. Consider this. I think you should. This is 0.0. Yeah. Consider that. I forgot to mention. Yeah. So you can calculate that. What is this value? So k. So k minus 20, so log 0.01 minus log 0.1 is equals to minus 40. So k minus 20, so this will become 10 power minus 10 power, yeah, it will become 3, so minus 120. hmm, yeah, it's plus 120, right? So yeah, so k equals to 140. So this is 140. So now overall system will become g of s h of s is equals to 140 by s square 1 plus 10 of ns. So this is the way you can bring it up. It is like a written way, right? This is all about Bode, how you bring it simple. So phase margin gain, yeah. If second order system, how to take? So if they mention second order system, no, they have to give the information of the damping zeta. Okay, they had to give it about zeta. If zeta is given 0 to 1, right, or more than 1, so they will mention it. So depending on that, you have to choose. See, this one is only happens because of the first order. See, two poles at origin. Now this one is one pole at, because you know that from here to here the transition will be what? Is only adding 1 0. So this is clear and this is clear. Now from here to here there is a two poles. Whether it is a second order like s square plus 2 zeta omega ns plus omega n square format, or s like s plus p1 whole square format. Two poles at some different. Same, right? So that means if they give such way, they have to mention about the zeta. If they are not mentioning it, blindly you take it. Agree? Yeah. Any other question? Okay. So we will meet in next tutorial session. Yes, yes. Which question? Today's assignment you are talking, which you are going to submit it. But I think it's supposed to not to tell anything, right? So if it is that, then, and anyway, you can read it out. If it is any hint, I can able to give. Okay, so they have given that second order system, right? So you need to find it out what rise time. Okay, okay, okay. So, but if it is, does it mention in the second order? Hmm? Yeah. Okay, let me open. Let me open. Yeah, let me open. Let me open. Yeah, yeah. Answers automatically they will be. There is an answers, no? Just below after submission, the evaluation will be there. If it is the correct on the green and red color, something colors will come, no? They will mention. Yes. So the third, what is that given? Which question it is? Your yeah. A step response of a system, they have mentioned it. Then the appropriate closed loop transfer function. So yeah. So mostly all the options is given as to be a second order system, right? So you know that all uh, formulas like maximum overshoot means e power minus zeta pi by 1 minus zeta pi by root of 1 minus zeta square is equals to 0.36, right? So from there you know the zeta. Agree? And next rise time what you have directly formula, something formula will be there in either. Yes, so see actually if you see, if you refer standard textbook, so what they say that rise time regarding rise time, so they will give that approximation. So even the rise time equation, right, rise time expression will be also a second order, like something like so some 3.5, some second order. If you open a book like Benjamin CPO, so they will give that exact second order, exact rise time formula. Okay, so advanced control system by BCQ. Okay, so then there exactly you can use that rise time. So from there you can get omega n, I think. So once you know the omega n, try to match it. So you can see that there are omega n might be the 1 or omega n might be the 9. So if you see this negative, it will not accept, either it should be only 1 or 9. So from those, whichever this coming to be zeta is matching, so then you check. So you have to mention, you have to make sure that zeta omega n. So whether zeta is coming that value, then you choose the right answer for that. Okay. Yeah. Any other questions, please? Fine. Yeah. Okay. Uh, yeah. Advanced control system by BCQ. What I need? Yes. Advanced control system by BCQ. KBCQ. I have mentioned right. Yeah. Let me give that perfect name. Benjamin CQ. So B dot C. Yeah. I've tried. Just check. You can check the message. So Anaga, what is that your question? PM for last, please. What does that mean? Uh, phase margin. Okay. Which question I need to repeat? Regarding Bode, right? Which I have done. Okay. All right. Okay, so now we know this transfer function, right? We know this transfer function. Now we are able to get it. From this, what you need to do, just make the phase plot also. Get the phase plot, right? It will be minus 180. See, let me draw here. Uh, so it will be up to this, it will be minus 180 till this. Then again, because minus 20 means it is going to be minus 90. It is minus 90 here, minus 90. Again, it is the same. So again, it is minus 270. It is moving towards minus 270. This is minus 270. Roughly, you can give it minus 1. See, now what exactly you need to do for phase margin, gain margin? You need to draw the lines, right? Exactly when magnitude will be 1. So see here magnitude dB, this is 0 dB line, right? Because y1 we got it as a minus 20 dB. So exactly at this point, we draw the line. So we know this one, right? So what is this here? So this is the phase which is often, this is actual phase. With reference to this, then you try to determine the phase margin, the difference of that. Now you see this is already almost like exactly at this frequency it is minus 180, right? So all entire this line is minus 180. So we don't consider. Then next you see again minus 180 line is touching at this point. See, now you draw this line. You draw the line which is close enough to this way. Now with respect to this, you see this is the gain margin. So this difference you need to find it. This is the gain margin. If both are positive, you can say stay stable. If it is a negative, so you can consider that. Okay, it's only built for only understanding concept. Okay, so uh, yeah, yes. Okay then. The, yeah, yeah. Okay. Okay. No. Actually, what exactly you are not able to solve this question that you are saying, right? Yeah. So only thing is that you need to make a fundamental so strong. Actually, the professor, if you take the basic control systems, so my point, uh, my point is that it is little advanced till starting. So because normally if you talk about LTI system, then after that time responses of first order, second order, and then calculation of bandwidth, calculation of resonant peak, and calculation of overshoots of first order, second order system. Then after um, root locus and all these things, actually what happens? So they go very slow. So my advice is that just you need to look into the basics of what are those systems initially. So how you make the plots very strong. Initially, it will be quite complex. My point is that because normally whatever first chapter, second chapter, first week, second week, third week, if you see that this will be taught entire semester. So now you need to be much quick to for doing this. You need to speed up this equation. So whatever assignment questions you have to. Only one thing you need to, you need to cover entire that chapter for one week. That is the thing. See, the week one, you need not to worry much. The week one is all saying that it is a transformation theory. So you need to do that because all control systems will not have that very complex like signals and systems. So either it is a first order system, second order system, then you need to be much familiar with what are those basics. So you have a Laplace transform table. So get those things. So try to make sure that those will be applicable for the any system. You can bring it to be standard of that. Okay, so that you can do that. You need not to study. That is only practice. Second thing, second one is all about that. You need to understand these plots. Like now you need to know that the Nyquist plot. So Nyquist plot is all about now today we have seen right. So that how we are drawing it. Same you try to implement those things for any type of functions for a some days like for at least for 2 to 3 numericals till you be very familiar. Okay, take some different type of those. Then what you need to do just by looking at the transfer function by knowing that magnitude and phase at omega equals 0 and infinite you should draw it. That's all. You need not to solve that what you can say coordinates like sigma plus j omega form. So that is only for understanding. If there is a crossover, then if they are asking particular about, then only you need to solve. Otherwise, don't solve. So those four steps you have to consider: zero to infinite, infinite to plus infinite to minus infinite, minus infinite to zero minus. So minus infinite to zero minus is the mirror image of zero to infinite. So again, zero minus to zero plus. Again, these two you have to look how many answer angle rotations it is happening actually. How much angle it is changing for one path. So then Bode plot is you need not to worry about it because like we are solved now, everything you need to bring it that format. So you need to identify the crossover frequencies, those crossover frequencies as per that, which comes first, whether it is a pole or zero. If it is a first order pole, you need to see that minus 20 dB per decade. And if it is a zero, plus 20 dB per decade. And number of poles at origin or number of zeros at origin, that it will. See, there is a second chapter in BCQ, Advanced Control System by Benjamin Keogh. He will speak very nicely about the Bode plot. Simple steps, 5 steps. It's of 4 pages. Read that. So Nyquist plot don't prefer the Benjamin C. Keogh book because what people practically they took that clockwise contour, but Benjamin here takes that anti-clockwise contour, so that there is a complexity of sign convention. Now we say that n equals to p minus z, they will say that n equals z minus something they say. Okay, because I always follow one, but only one thing is that practice is the most effective parameter for getting this. Even I didn't have this much because I will be facing issue when I was doing initial time. But thing is that it is all mathematical oriented. But as you keep on doing some practice of different things, definitely you will do good. But don't see the development that at this initial stage. At the end of this course, you might be feeling very good. I think so. If you have a constant work. So by the way, which university you are doing? Triple ITD. Okay. Then indoor, right? Yeah, Kannur. Okay, good. So solutions now nothing can be done because as soon because we are just supposed to give only